Alrighty then. Okay. You guys ready?
Yeah.
I can't hear you.
Aye, Captain.
Oh.
Who lives in a planet under the sea?
Absorbent and yellow and porous is he.
SpongeBob SquarePants.
If nautical nonsense, that's what you wish,
SpongeBob SquarePants.
then drop on the deck and flop like a fish.
SpongeBob SquarePants. SpongeBob SquarePants. SpongeBob SquarePants.
Alrighty. Okay. Okay, so basic differentiation. So this is the good stuff. Okay, this is the non-algebra, make you cry stuff. So this is the easier stuff. Easy. Several different notations for derivatives in calculus. We'll use two different types interchangeably throughout this. And so one way to actually say it would be, if we were to talk about it, it would be like y prime would be one way of actually saying the derivative of y. Or another way would be to say dy dx, which means we're taking the derivative of function y with respect to x. So, yes. And, yeah. Okay, so that's other ways of doing it. Okay, derivative function notation depends on the function as shown in the following. So if it's g of x, we write g prime of x. Second derivative, g double prime of x. I'm sorry, f. Why am I saying g's? Anyway, all right, f of x, f prime of x, g double prime of x. Same thing goes. I did it again, didn't I?
Yeah.
Okay, so f double prime of x, and then the next one, g prime of x, g double prime of x. And then when we get down to y's, it could be y prime or dy dx. So these are important. So y double prime is d squared y over dx squared. Okay, so now, if you notice the notation, so it's d, so second derivative d, right? D of y, right? Of y and of x, d of x. Okay, second derivative of that. Okay, so super important that we understand what it's asking for, what it gives us. Okay, so power rule. So power rule means I take the exponent, I multiply it out front, and then I subtract 1 from the exponent. That's the whole power rule. There it is, right there. Bam. I subtract 1 from the exponent, right? And whatever that value was that at the exponent, it multiplies out the front. Okay, so notice when power of function is negative, the power of the derivative is more negative. The reason why it says more negative is it's getting a bigger negative. Because if it's negative exponent, when you move it back to the denominator, it's going to become a bigger number, right? So every time you subtract 1, it's going to give you a bigger number, right? So yeah, so if it's a negative, if you're subtracting, if it's negative 2, it gives you a bigger negative. So it makes it a negative 3 after you do the derivative, okay? So that's what it means by that, is more negative. Okay, so a couple of examples. Let's take a look at the u1 right here. So again, so u equals x 1/2. So u prime would be, the 1/2 goes up front, and then it's x to the 1/2, and then I have to subtract 1, which is just going to give me negative 1/2. All right, so now the exponent written in a fraction is so helpful, because you're going to get some nasty ones that have some ugly exponents. Ugly exponents, like 3/5. Okay, so 3/5, which would mean it's the 5th root, but the 3rd power. So if I were to, if it says x to the 3/5, what that translates into is the 5th root of x to the third. Yes. Ugly exponents. Okay. I hate seeing it like that in radical form, but as an exponent, okay, so would I be able to subtract 1 from that? Say yes, I could subtract, because the 1 value would be 5 over 5, wouldn't it?
Yeah.
5 over 5, so I subtract 5 over 5. So the derivative, so if this is u, right, the u prime would be 3 over 5, and it's x, so subtract 5 over 5, negative 2/5, right? Negative 2/5. Because it's 3 over 5 minus 5 over 5. Okay? So, like I said, you're going to get some ugly stuff, but it's not so bad. You know what? Fractions are your friends, not food. Okay? Oh, okay. Anything to 0 power? 1. And what is the derivative of 1? 0. The derivative of 1, it's a constant, right? It's a constant. So if it's a constant, it's going to give me 0. All right, right here. Oh, hey, look, the exact same thing I just said. So derivative of x would just give me 1 because that goes away. Then there's my constant. And then of just a constant is my 0. Okay, let's see. All right, so here, I'm going to cover up this one so you can't see the answer there. All right, so it's y equals 8 x to the 4th. I know it's still written on your paper, but come on. It's for the sake of people on YouTube land. All right, so now, I'm going to do the power rule, so that means I'm going to take that exponent, multiply it out front. So 8 times 4 gives me 32 x to the third, because I'm going to subtract 1. Okay, and that would be my y prime. There we go. Yes? Okay, so all the rest of them are pretty basic and same thing. So I just wanted to do one of the examples for this. I hate skipping through all these. Okay, here's that constant right there. So constant, there is no variable. So that means that the derivative would be of that would be 0 because it's going to be a constant line. Okay, so now this is in between 2, a and b are 2 constants. So it's basically this term plus this term. So we're just taking the derivative of each term in a polynomial separately. So if there's a plus sign in between them or a minus sign, great. Just take the derivative of each piece individually. So, okay, again. All right, so let's see. So if it's y equals 3x to the 4th plus 8x to the 10th. Okay, I multiply out front. So 3 times 4 gives me 12. X to the third, right? Because I'm subtracting 1. And then it's going to be plus, okay, it's the 10 times the 8, which gives me 80. X to the 9. There we go. Now, getting into some ugly stuff down here. So this problem right here gets into a couple different things. So I could distribute that, right? I could distribute that, but I've already taught you guys other ways of doing this, right? What would be the other way to do with this one? The product. This is being multiplied. I have 2 functions, 2 quantities, 2 binomials being multiplied together. And so I could actually just do it as a product rule, or I could expand it. So if I expand it, then I would come up with, if you notice, look, 1, 2, 3, 4 terms right there. Then just take the derivative of each piece, each term in the polynomial individually. Yeah? Okay. Questions? Are we good still? Okay. All right. Okay, the k over x. So remember, we could bring that x up to the top as a negative exponent. That would be k to the x, I'm sorry, x negative, I I know, right? X, -1, like that. Then as we do my derivative, the negative goes out front, and then I get a bigger negative, right? And so as I bring it back down as a positive, it would be a -k over x squared. Okay? Same goes for here. But this one has a fractional. It's the same thing. Higher order derivatives. So taking the first derivative and then the derivative of the derivative. So if we start with the function of x to the 6th, it's 6 out front, right? Then x to the 5th. And then the second derivative means the derivative of the derivative. Then it's going to be the 5 times 6 gives me a 30. And then my exponent is going to be to the 4th now. Yes? If you guys got questions, please speak up. If you guys want highlighters, I got highlighters in the back too. I noticed a couple people looking for that. Yeah, maybe. It's in the back. They're in the bins. I use them for my what class I teach? Algebra 3. Yeah. All right. Let's see. Individually.
What color you want?
All right. So if we were to look at this, and we've already done a whole bunch of these, and all these ones right here are straightforward. Okay, I'm going to give you guys 10 minutes on this again. You guys go through, look at some of the problems, and try these out. Practice them yourself. So 10 minutes on this. All right, so this video right here, I'm going to pause it. So I'm pausing this one right here because... Yes, I am the onceler. I speak for the trees. All right. Okay, going back over this because if I turn the lights out, someone's going to fall asleep again. All right, so product rule. Product means that there's a multiplication happening in between two separate things. So in that multiplication, I lost my smart pen. It went doggo, then all of a sudden smart pen gone. Oh, there it is.
It does look like this paper.
I know, right? Okay, so doing this, so if you guys see this right here, this and this is a 4 times a 3. It's kind of a pain. It'd be a pain to do all my distribution, right? So a 2 by 2, a multiplication of just a FOIL of a binomial times a binomial, that would be fine. Okay, but once you're getting into this, too much work. All right, so let's go ahead and, yo, look. They expanded it. That's ugly. Yeah. Oh, that's nasty. All right, so what we're going to do is, okay, so I need you guys to read it for me because I'm going to put it on a new page. There we go. All right, so it's going to be what?
9x squared.
9x squared.
Wait, I'm looking at the wrong one. My bad.
X to the 8th, right?
Which
What
one?
are we talking about?
The first one. The highlighted one?
This thing right here, I circled it right here, x cubed. This thing right here, because I don't want to expand all that. Okay, let's, all right, so now,
X cubed
x cubed.
plus 5x squared minus 4x plus 1 x to the 5th
Minus 7x to the 4th.
plus x.
Like that?
Yes.
Okay, good. All right, so product rule. Again, okay, so as we're going through doing this, if you label everything, and y'all got some bad habits, I blame your last year's teacher. Label, show work, and use a lot of space, please. Use a lot of space. So we're going to do a couple things here. So first, I'm going to label it what it is. So this is F, and this is G. So the product rule is going to look like this. It's F prime G plus G prime F. That is the product rule, where F prime and G prime is referring to the derivatives of their respective functions. So, off to the side. I like going off to the side over here because I'm actually showing more work. Okay, I'm labeling everything so I don't screw it up. A lot of times, seriously, typos are going to kill you. So if you're going through and doing problems, let's say for instance you bring up a problem to Mr. Pacho and you have sign of nothing over x and then you're like, oh, that's what it's supposed to do, how do I do this? And I'm like, no, you have to write out the whole thing, and then you realize there's something wrong. Okay? So if you make sure you write it all out, typos, little things going to get you all the time. So f prime. So f prime means that we're going to take a derivative of f, which is going to be 3x squared plus 10x minus 4. And then g prime is going to be 5x to the 4th minus 28x cubed plus 1. Yes? Okay. So from here, I'm going to go through and I'm going to just plug in f prime g plus g prime f. So f prime g, so that means it's going to be 3x squared plus 10x minus 4. There's my f prime times the g, which is x to the 5th minus 7x to the 4th plus x. So that's all of this right here. Plus g prime f. G prime is going to be 5x to the 4th minus 28x cubed plus 1. And then there is my f, which is x cubed plus 5x squared minus 4x plus 1. That's a 4. Okay, so that's all that. Now, good thing about this. Set your pencil down and leave it alone. That's it. That's it. Leave it like that. Because on the AP exam, this is showing proof that you know the derivative.
And that's all you need?
That's all you have to do. You don't have to do all that expansion.
Yay.
You could just stop right there. If you did your f prime g, g prime f correctly, that's fine. But the problem is, if you go to this, this is correct, but then you do another step, and then you forget a minus sign or something, and your next answer, your next line is, let's say there's a minus instead of a plus. You went from getting points on it to no points on it. Getting a yes versus a no. Okay? Just because you have the right answer here and the wrong answer here, they go with the last line of answers. So if you have something else down here that's wrong, they go with the wrong answer. Kind of like some of you people that decide to put two different answers on your thing saying it's this or this, and just so you know, I mark them both wrong. Even if it is right, one of them's right, but no, they're both wrong. Okay? So, yeah. So it's not a multiple choice test for me, okay, for you. You don't just say A or C. Yes, okay, but no, you're both wrong. All right, anyway. Oh, wait, where was that? So there is my product rule. This is one way that you might see this written, okay, with the U's and V's. I like doing F's and G's. That's the way that was written in the book. That's the way that sometimes you'll see it with a U and a V. So now if you notice right here, it says dv dx. So that means the derivative of v in terms of x plus v, which whatever the function v is, and times the derivative of u in terms of x. Did I screw up again? No?
Just that, just function is like whatever the function of v is.
Yeah, whatever the function is. Okay, all right. I think, laughing a little bit too much. Come on, we're doing math. Either that or we're getting a little bit senile at this.
You're right, math isn't funny.
I know, right? So laughing at my jokes is the first signs of madness.
Spelled it wrong. Wait, is that how you spell that?
That's a pun. Yes, that's sine. That's like sine, cosine, tangent, sine.
No, I got the joke. It's just I don't remember sign being spelled out. There's an E. I don't remember the E in there. I know. I get the joke. I just don't understand.
Wait, what was the key?
Okay. Now, a keypad on your calculator just says SIN, right?
Yes.
Because it's only a 3-letter abbreviation. And you know the other one is not cos, right? What is it? Cosine.
Oh. You guys know.
And it's not tan,
Oh my god.
Oh my.
tangent.
We're in a class full of bozos.
Pacho's Petting Zoo. Okay, can you send him down over here, please? Okay, so someone could go and find him. All right. Okay. Goodbye. All right, Patar, go find the pizza guy. No, walk him back over here. All right. So now, yeah, he up towards the front office. All right. So he's supposed to be wandering this way, but yeah, find him. All right. So yes, sine, cosine, tangent, right? Okay. Signs of madness. All right. Okay, quotient rule. Quotient rule is if I have a u over v, there is a function of u divided by a function v, right? So it's basically I have a polynomial on top, a polynomial on bottom. So I have a variable on top and a variable on bottom, and they're both, in these terms, going to have a variable of x. Did you really just take a bite out of that and just walk and like bring it back?
I tore it.
Okay. I know, but you still touched it. That's like, ugh. Anyway. All right, so quotient rule. Now, the way that we're writing quotient rule, I write it slightly different because I write it to match the product rule. So you just know that the product rule and the quotient rule have the same in the same order, but there's a minus sign, right?
Yeah.
Okay, so this is going to be f prime g minus g prime f over g squared. So you'll see it written different ways, but there's a reason why I write it the same way all the time. This is the way that was actually taught in the book. And yes, they vary a little bit, but it's the exact same thing. It really is. Okay? So let's go ahead and...
Which one do you think is going to be on the test?
It's all there. No, it doesn't. No.
Yeah.
Okay, you're going to see stuff written like this, right? Okay, what does it say? So this says a v, right? Whatever the function v is, times the derivative of u in terms of x, right? So that's the derivative of u. So that would be u prime. So in this terms, it would be v times u prime, right? Minus, so u, whatever the function u is, right? And then dv dx, so that's the derivative of function v in terms of x. So that's going to be times v prime all over v squared. So it's written every single way. So it's kind of like knowing the same word for, three different words that mean the same thing. Yeah. So, yeah. It's all the same. It just depends on how it's being used. Maybe? I don't know. Okay. So, yes. You're going to see this, but I always do short notation like this, which is a little bit easier. Okay? That's the reason why I actually use that all the time.
What?
No, it's true.
Yes.
What time are we going to do that?
You're done in 10 minutes.
No. Like, are we going to go all over this?
Oh, yeah, well, I'm pretty sure we finish up with this. Yeah. All right, so let's see. Quotient rule. Okay, so. All right, so I'm going to do this one right here. So number 4, right here, example 4, I'm going to do this one. So can you please read me 4? So what was it?
X to the 5th minus 3x to the 4th over x squared plus 7x.
Like that?
Yes.
Okay. So in these terms right here, this is my f, this is my g, and let's do the f prime. So f prime is the derivative of f, which is going to give me
5x to the 4th minus 12x to the 3rd.
very good. And then g prime,
2x plus 7.
very good. So from my notes, f prime g, right?
Yeah.
F prime g, so it's going to be 5x to the 4th minus 12x cubed times f prime, then times g, which is,
Squared plus 7x.
yep, x squared plus 7x minus, right, g prime f, 2x plus 7, f is x5 minus 3x4 all over g squared, right? So that's going to be x squared plus 7x squared. Now, like I said, this right here is considered done. Okay? This is all done from right here. So you don't have to expand it. And that's the reason why this is so much easier. You don't have to do all my expansion. You don't have to do anything else. So if anything, if you did want to try to match your answer. So you would see something like this on a multiple choice where you would have to match your answer with what they have the choices of. Then you would have to go through and expand and see if you could factor anything or cancel anything. Okay, you would do the best you can from that. Okay, so that being said, here's the quotient. Okay, so there we go, right here, and then to the chain rule. Chain rule, one of my favorites. Okay, so it's written a bunch of different ways. It's written a bunch of different ways all the time. Okay, now if you understand inside outside. Okay, there's a possibility that you could actually have things with 2 chains, multiple chains. Okay. All right, so multiple chains. So now, in this case right here, this would be just the case of right here. We have combining of both of those. So we have 2 different parts. So f prime, okay, so f of g of x. So that means g of x goes into f of x. Okay, so this, the value for g of x, which was here, goes into f of x. So you replace your x value with what you have here. Does that make sense? And another way of actually writing it is f of g of x. So that means that whatever value you have for this goes inside your f. So we could actually have it right here. Or if we do the other way, which is g of f of x. So that means the value for f of x, which is right here, 1 over x, gets plugged into the g value where you have x. Okay? So, let's see. Now, this is all weird and complicated, isn't it? Okay, so let's actually go to some problems to make it actually a little bit easier. Those are ugly. Those are ugly. Ugly, 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 ugly. Nope, I don't want that. Okay, I like this one. So you guys are going to read this to me as I go to this one. Page. All right, go ahead.
X plus 3 over x minus 3.
Okay, so now we have a couple things going on here. So the outside, I would consider the outside, especially because I have an exponent in here and I have right here. So I have quotient inside and on outside. So I would basically consider all this right here the outside, the u, right? So it's basically saying it's u to the third. So, huh? Yes, it's u. Okay, so if I take the derivative of the outside, it's going to be like 3u squared, right? Okay, so I'm going to put 3, but now the u value is x plus 3 over x minus 3, right? Squared. Okay, so that's the u value. So that's the outside. But now the inside times the derivative of the inside. So the derivative of the inside, we have f is, because it's a quotient, x plus 3, f prime is 1, right? Okay. G is x minus 3, g prime is 1. So I have the quotient on the inside, right? So it's this times the derivative of the inside. So it's times the derivative of the inside is going to be f prime g. So f prime g, so it's 1 times x minus 3. Yes? Okay, so since it's quotient, this is going to be a minus sign right here. And then it's g prime f. So g prime is going to be 1. And then times f, which is x plus 3, all over
X plus 3 squared. Minus 3.
there we go. So it's x minus 3 squared. Okay, so on the top, I would clean up the top of this. So technically, this is all correct. Okay? This is all correct. I would clean this up just for the sake of, because it might do something special. Let's see. It's going to be, clean this, 3 quantity x plus 3 x minus 3 squared times, so that's going to be x minus 3, right? And then it's, since it's distributing that, it's a minus x and a minus 3. Okay, so what's going to happen to my x's? There, it's going to cancel, right? So that's the only thing. That's the reason why I was able to do that. There's no squares. There's nothing too complicated. Usually if there's nothing too complicated, something right here is going to usually happen. You're going to see something go away. So in this case, my x's go away. So it came up with a negative 6 over x minus 3 squared times x plus 3 x minus 3 squared. So what else could be a variation to this answer?
Distribute 3 to the -6.
Yes, I could distribute the 3 to the -6, or I could distribute the -6, right? I could put all of it out front, right? Okay? So I could do that also, and there would be a 1 right here, right? So either way, it's going to come out similar. Okay? Negative 18. And times x plus 3. There we go. Yes? Okay. All right.
Took it a step further.
And squared the top and squared the bottom?
Yeah, and then they like add.
So you're saying you went like this, and say negative 18 over x minus 3 squared times x plus 3 squared over x minus 3 squared, right?
They put this.
And then it's going to be a total of negative 18 x plus, plus 3 squared over x minus 3 to the 4th power. There's another variation. All these are right. That's right, that's right, that's right. This is right, and this is right. The reason why I say it like that is because a lot of times you might see this on a multiple choice. And then you have to match your answer with what they have. Okay? All right, let's see. I think I'm almost done here. So chain rule. Yep, I think that was it. That's a product set 5. Oh, trig functions. And you know what? I think I'm about out of time too. Yep. Okay, so sorry about that, but it is 12:01, and then they're gonna yell at me that I need to clock out here. Don't forget, like, share, and subscribe.